Here is an example of a linear equation in function notation. And we want to evaluate the function and then graph those ordered pairs on a coordinate plane. So in function notation, you say f of x equals 5x plus 2. Or replace that f of x with the letter y, equaling 5x plus 2. They mean the same thing. This one is represented as a function. So what we're going to do is we're going to choose some values for x. And we're going to substitute it in for the x in the function. So I'm going to start with 0. Remember, 0 is going to go in for x. So I say f of 0 is 5. Replace this x with 0 and then plus 2. Now we need to simplify it. So 5 times 0 is 0 plus 2. And then 0 plus 2 is 2. Now, choose another x value, let's say 1, and we're going to substitute it in for x. So f of 1 is 5, replace the x with 1, and then simplify this. So 5 times 1 is 5, plus 2 is 7. Now our last one, substitute 2 in for x. So f of 2 is 5, replace the x with 2, and now simplify. 5 times 2 is 10, plus 2 is 12. What these red, green, and purple things represent, they will be ordered pairs on our coordinate plane. This ordered pair is going to be what you substituted in 0, that's your domain, and what you get out is your range, which is 2. So there's our first ordered pair. Our second ordered pair is what we substituted in, f of 1, so that was our domain, and then our range is what we got out, which is 7. Our last one, when we evaluated 2, f of 2, which is our domain, our range, what we got out, was 12. So what we're going to do is we're going to graph these 3 ordered pairs. So what do these things mean? They are your ordered pairs on your graph. So let's graph the first order pair, 0, 2. Here's 2. We're going to go over 0 and then up 2. And that ordered pair was red. Let's keep it the same color. So over 0, up 2. And let's just label it. Then the second ordered pair that we found was 1, 7. So we'll color that one in green. So we're going to go right 1 and then up 7. And then we'll label it. And then our last one in the purple was over 2, up 12. And notice we have a constant rate of change, so we can go ahead and connect the dots and create our line, which is our linear function.